all the gases, everything that you just saw coming out here, that is actually fuel, which is like liquid oxygen, I believe is what they said it was. I don't think it's going to be the kerosene, but the liquid oxygen, which they needed to drain the pressure from this arm right here, the strong back. So it is no longer attached, and you see, I mean, it's super cold. Oh, yeah, super cold, and so you can
10,
see all of that.
9,
And
8,
here we go.
7, 6, 5, 4, 3, 2, 1, 0. Ignition, liftoff. Simplify, aim high. Go Falcon, go Dragon.
Vehicle is touching down range.
T plus 30 seconds. Falcon 9 with the Crew Dragon capsule is heading east from pad 39A. Everything looking good right now. As we get ready for max dynamic pressure, we are now throttling down the first stage engines on the Falcon 9.
Telemetry nominal.
So in probably about 30 seconds here, they're going to actually be shutting down those rocket engines. That's going to make the computers on the... Oh, almost there. That's going to make the computers think that there's an issue and trigger the flight abort test. So this is all going to be on the computers.
Okay, the major activity coming up in just
Here we go.
10 seconds. Shutdown and Dragon escape from the Falcon 9.
And there we go. We can see it successfully, almost instantaneously. You see it start breaking away. It's flying away. Now that's what will carry the crew to safety. And there's that explosion.
Okay, you just saw a bright flash there. It looks like that may be Falcon 9 breaking up.
There's a very...
here in Hawthorne, the folks that just watched live the Dragon separate. The next milestone we have coming up at 2 minutes, 25 seconds, we're expecting to see the trunk jettison. So that claw that connects the trunk to the capsule is going to separate, allowing Dragon to separate from the trunk.
Biggest thing why you don't want the trunk off right away is it has these fins right here. These fins right here really help it stabilize while it's going up. And okay, so they don't need it. They've reached their apogee. That means they've reached the highest point that it's gonna go.
Really loud cheers here in Hawthorne, California. This test is looking great so far.
Nice view from the back of the Dragon capsule. We're also trying to see if we get the view there on the right-hand side from the aircraft. It's orbiting the area. Now the Dragon control system is now going to be reorienting the capsule. We're at a high altitude where the aerodynamics are negligible. So we're going to use the small Draco thrusters on the Dragon capsule to reorient it. That gets it in a position with the heat shield down to re-enter the Earth's atmosphere, and then later to deploy the drogue parachutes.
Now those drogue chutes, we expect to get confirmation that those have deployed at T plus 4 minutes and 48 seconds. So we've got just a little bit of breathing room before we hear that happen. Those parachutes are protected during ascent, on orbit, and re-entry by a panel that's up near the nose cone of the capsule.
So one of the really cool things...
So we're going to jettison the panel, then the mortars will fire to deploy those 2 drogue chutes. Again, that's coming up in just over a minute at T plus 4 minutes and 48 seconds.
One of the really cool things is that the way aerodynamics work is capsules, they actually want to fall the way you want them to fall. You would think that they would want to flip and have the nose cone down, but that's actually not true. The way aerodynamics work is it's automatically going to want to orient itself so the flatter part at the bottom is coming down, and that makes it great for putting a heat shield on there, and as well as slowing down the capsule. And so what it's doing is you're seeing these small little thrusts. Oh, here we go. The small little thrusts that you're
We
seeing
expect
here
that will happen when Dragon is at
is just
about
keeping
20,000
itself in
feet.
the perfect in the perfect orientation. You know, there's a lot of wind and everything up there to affect it, so
About
it's just trying
15
to offset
seconds
it.
to drogue chute deploy.
Okay, there's our drogue chutes.
And there they
The
are.
initial slowdown,
Drogue chutes are out.
and that's actually going to pull
Again,
the
some
other
major
parachutes
cheering
out.
going on here as every stage of this test unfolds. Now we're going to be getting ready for the main chutes to deploy.
Now, main chutes will be coming up fairly quickly. There are 4 main parachutes. These are the newest Mark III parachutes. They're each 116 feet in diameter. We deploy them about 2 kilometers above sea level, 6,500 feet above the Atlantic Ocean. We're getting good views from the Dragon and the airplane, showing the 2 drogue chutes. Now we're just waiting for the main parachutes to be deployed very shortly. And we have the view from a different
And-
camera on Dragon showing the 4 main parachutes.
Looks like all good.
Now they are deployed in a reefed condition. That means we're keeping them fairly shut to avoid shocks, and now we're slowly opening up the 4 parachutes. Great
Looks
views
like good
coming off
deploy.
of the Dragon camera on the left, and we can also see the 4 parachutes from the airplane on the right.
That is a really cool view.
Nice view of the orange and white parachutes as they're opening
And they're
up
still
into
not
the
even
second
fully
position.
deployed.
And then going to fully open. From fully open, we'll be descending about 20 to 25 feet per second down to the Atlantic. So from that 6,500 foot altitude, it's going to take us a few minutes to splash down. Also right now that the mains are out, a sequence is performed on the Dragon, which will reorient the crew seats into a splashdown position, give them a little better angle to take the slow bounce as we hit the ocean. Now, Maria, I talked about the parachutes came out initially at a reef condition. That's fairly standard. They come out not fully open. That way they're minimizing the shock on the parachutes. We're also minimizing the shock on the capsule. Again, we want to give a smooth ride to the crew as they are coming back through the Earth's atmosphere.
Right.
Now, the parachutes are located behind a door that's at the bottom of the capsule. It's below the crew hatch. So Dragon commands the door to release, and as you saw in the video, the drogue parachutes pull the door away, and that pulls the 4 main parachutes out. Now, these are the new Mark III parachutes. We've completed here at SpaceX over 80 tests of that parachute system, including 10 multi-parachute tests of this particular upgraded parachute design over the last few months to demonstrate that the design is ready for flight.
And we're just inside 2 minutes of when we expect to see splashdown. The recovery teams are already out there in the Atlantic Ocean standing by, ready with fast boats to begin their initial approach to Dragon. Again, we mentioned this before, but the recovery operation we expect to take a couple of hours.
I've heard a call out, we're below 500 meters.
And we expect when Dragon splashes down, it's going to be roughly 32 kilometers offshore. Again, we're looking at a live view. So far, all things have appeared to go nominal for this test. All things looking great so far. We saw the 4 main parachutes deploy. You're looking at them now, fully open. And we are coming up on about a minute until splashdown.
And so
I think we may
this
have heard a call out of 100 meters to go.
view right here is
Yeah, I
actually
just
from a
heard that
NASA
too.
plane that has a lot of specialized equipment, specialized cameras to see pretty much every little thing that they can from this test. And then this is from a camera on board the Crew Dragon.
Now those 4 parachutes are actually going to be released from the capsule
And
after
splashdown. We have
splashdown,
good
and they'll be
splashdown.
recovered too.
Yeah, I
And
guess
we are
this is
down.
going to be a view from, it looks
Down
like
a little bit early, in
right
fact.
here, yes, some rescue craft right here, just coming
And there
right
you
on
can
in.
see the recovery boat beginning to approach instantly. I'm going to try to talk a little bit louder so you can hear me over the folks here. This has been a really exciting thing to see because we had the weather. We weren't really sure if the weather was going to cooperate.
This was really, in all honesty, the perfect test perfect test that could have happened. There really was not any problems. As you saw, the Crew Dragon just launched almost instantaneously. I'll try to pull that up to watch it again really quick. Let's see.
Headed out there, and you can also see it looks still a little choppy, so you understand we were kind of on the edge of the weather conditions out in the splashdown area, but they assessed the boat data, the buoy data, looked at the forecast and said we were go. And while we took 2.5 hours to get here, we finally got here and it was great. And that's the summary for today. It looks like right now a great test. Visually everything happened. Falcon 9, you saw the liftoff. We had kind of a long view from the camera. Dragon did shut down the 9 Merlin 1D engines and separate. We did see the flash as the Falcon 9 came apart, as predicted. No surprise there. Dragon, we saw a great view as it got to apogee. It deployed the trunk, separating it, reoriented. Then the drogue chutes came out, the main chutes came out, and then we just waited for that nice soft splashdown in the Atlantic Ocean.
And we saw, and it looks like we just lost the view from out there on the ship, but you couldn't really see much from that particular angle. Again, that recovery operation is going to take a couple of hours, so we're not going to stay on the air for the duration of that. But we are going to be back for a news conference coming up at 11:30 Eastern time this morning. That would be, let me do the math real quick, 8:30 Pacific time. We're going to hear from NASA and SpaceX leaders about their initial thoughts on this test that you just saw. Of course, everything looked fantastic, but there's going to be a lot of data to dig into. They're going to also collect those parachutes, get a lot of data from that, and then see what the next steps are on the path to Demo 2, when, of course, we're going to be launching NASA astronauts Bob Behnken and Doug Hurley. So stay tuned for that news conference. It will be carried live on NASA TV. If you're watching on the web, just tune to nasa.gov/live so you can see that coverage. Again, that's 8:30 Pacific time, 11:30 Eastern. Thanks so much for joining us for this morning's test.
Alright, here's what I'm going to do really quick. I am going to take us back just to right before here. Alright, hold on. Give me a quick second. Move myself right over here. Because I do want to see that, but I want to see it a little bit slower. Here, let's actually right here. Nobody really wants to hear that crackle. And I think we can right about here, actually. And you can see, actually, really quick, right here, you can actually see how it's getting bigger right here. That is actually because the air pressure is lower, higher up in the atmosphere than it is at launch. So at launch, you actually see this pretty much steady stream straight down from the rockets. That's because the air pressure is actually holding in those exhaust fumes at launch. But as you go higher up, the exhaust fumes actually expand more and more the higher up you get. You actually will get these massive fumes, just, double the diameter of the rocket sometimes. And the struggle that's always with space, with rocket launches, is performance and efficiency. So that's why 2-stage rockets, sometimes even, I think we've seen 3-stage rockets, can be the highest performing, is because when you get higher into the atmosphere, you actually want to have a larger diameter rocket nozzle, that bell at the end, and that's actually what pushes the rocket forward, because those gases hit the side of the wall, and expand, and that pushes the rocket forward. And so that's why you can see right here, they're actually expanding. You can actually see it right there. And right there, I mean, you can actually see it. 4 to 5 seconds. There is. Hold on. There. So right there, you can see that's when they cut off the engines, and a frame later, you see Dragon right here is already. I mean, engine cutoff is right now, and Dragon's off. So it took what looks like less than a second to actually have Dragon realize there's a problem. I gotta get out of here. And so Dragon capsule is launching. It's using those motors to launch itself away. And what's happening right now is because it doesn't have that smooth nose cone over the top of it, the aerodynamic forces are hitting the Falcon 9 rocket unevenly, and it's going to start to spin. That spin is going to cause a lot of pressure and the uneven pressure, uneven force all over the rocket, and that's actually what's going to cause it to break up. So they didn't tell it to explode or anything like that, but it actually broke up and exploded because of the uneven aerodynamic pressures. Right there. And you can actually see, I mean, its pieces are still going forward. That's the one. Let's go. Okay. So you can actually see it looks like it's actually starting to break up now, and that's when the tanks actually finally just broke, causing that massive explosion. But and then a secondary one, it looks like right there, but it's going so fast that everything's going to keep on going. It's not just going to explode and drop. It still has all that momentum, all of that force that's going to kind of propel everything forward. And I mean, Dragon is not in that at all, so that's actually, you know, it's not something that we have to worry about at all with Crew Dragon being in the vicinity of that. It looks like Crew Dragon may actually be, it looks like, well, right there. Let's see if we can go back. Okay, so yeah, I mean, you can see Crew Dragons right there, so it's well away from the rocket. That's how fast these Super Draco thrusties take this rocket is. You see how far away it is. Right there, it's still right there. The camera's tracking it. And the explosion of that, still you can barely see it, but it is still just right there. And that Falcon 9 explosion, when it happens, I mean, this capsule is far enough away that even with the explosion propelling things faster, there's not any chance of harm to those astronauts, which is really, really good. You know, we saw a lot of safety, a lot of everything going right with today's launch, today's test. And so these will fall into the ocean. The reason why we can only have so many windows, or so long of a window for these tests, even though they're not trying to get anywhere, is because they have to actually close off areas of the ocean that boats can't go into, that planes can't fly over. and so they really try to minimize the impact of that. So that's why we only had a window of launch. It was like a 6-hour window, but still. And you can see the explosion, everything right below there. And once again, these fins are built in to allow stabilization as it goes up, as it goes through the atmosphere. And then that trunk is no longer needed. While yes, it does hold a lot of supplies in the case of in the case of carrying supplies up, when it comes back down, I believe it's actually just loaded up with trash from the space station, junk, things they don't need back on Earth, and it disintegrates through the atmosphere, so there's no worry of anything of that in the case of coming back to Earth from space. That would just break up. And everything on here, everything on the rocket was loaded to weight, so it's loaded up as if it was a full rocket, as if, everything on there was slated to go. It was, the weights were all the same as if it was going to the space station. They actually had on the second stage of the Falcon 9, where normally you would have a MVAC engine, a Merlin vacuum engine, they actually put an old an old Merlin engine that would never be used. It was an old test engine, and they actually loaded it up on there because they wanted everything to be as close to what would actually be launched. And so right now, right here, once again, you're going to see we're going to be hitting apogee. And when we hit that apogee, that's when you get rid of this trunk. You want to get rid of it when you're closer to apogee, because you don't then have an issue with the trunk hitting the underside of the rocket. Everything is then just going to be falling downwards, and with the trunk below you, it's going to break apart, or separate, and they're going to fall separately. You don't have any worry of it bumping into each other. So that's why you have that. And you can see that trunk right here. And you can see right here is just that Dragon capsule. So that's the exciting thing. Everything went really, really well. I think this is going to be a huge step forward. I think they're hoping for a March launch of astronauts. So this is a very, very quick turnaround of going from this test to actually launching astronauts. And with that, they will, and once they launch astronauts, they will be testing that. Just saying, hey, yes, everything's going great, and I believe that one actually will go to the International Space Station. So this, what we saw right here, was the last major test needed for verification of human flight. Now there's still a whole lot of sensors inside that Dragon capsule, taking information in, taking in a bunch of data. NASA's going to review it, SpaceX is going to review it to verify everything went as planned. But, as long as you didn't see something wrong with the capsule, no breaking in there, nothing like that, as long as you saw all that, then we're essentially going to be good for human spaceflight in that Dragon capsule. And as Jim Bridenstine, the director of NASA, likes to say, American astronauts flying from American capsules on American soil. He loves to say that. That's his big thing. So hopefully all that data comes back. I think pretty soon it'll be coming back, and that's why we're actually going to, here in about half an hour, have that press conference where they'll be going over some of that preliminary data. I'll be sticking around for that, and then we will see how all that goes.